Hello, good afternoon. Welcome to the stream. And I see just a few of you here right now. Pretty excited about today's stream. It feels like forever since I streamed. Maybe it's because last time I streamed on a Monday and then again on a Sunday. But here it is, Sunday again. Anyway, I wanted to take a break this week from doing hard hat things. It's kind of in the position where I think the work that needs to be done on it is not particularly interesting to do on stream. So it's mostly the documentation, and then possibly some extra tests, maybe some integration test of some sort. We'll think about that for future streams. But today, my internet pal, Mitch Hanberg, the Elixir Tools guy, had pinged me a while back and said, hey, why don't you, I'm working on NextLS, which we've been using the last few weeks in Z as an alternative to Elixir LS. So he's working on NextLS and he needs access to the AST. And a lot of the other language servers use this library called TreeSitter, which is the library that GitHub is using behind their semantic code search and stuff like that. It's really cool stuff. It's based on some of the more recent research into grammars and parsing languages. So he said, hey, why don't you, do this on stream? Well, I got a little bit antsy and I started doing it the other night. So we are going to jump into that later from where I am, and hopefully we'll have some fun. I don't know if any of you have worked with NIFs before, but I'll explain what they are, why we care, what they're useful for, and then we'll get into the code that exists and we'll talk about building that out. I think it should be really fun, mostly because I haven't written NIFs in a long time. I'm learning new things about them as I do it, and it's pretty cool. But first, and I might as well just switch to the coding string scene because I'm literally reading from the buffer I have about what our agenda is. So I want to finish up parsing Datalog programs. We got started on this last time, and this is where we were. Because it's an excellent demonstration of NOM, this great little library of parser combinators for Rust, and then we just have we have gotten a lot of it already. So we just have the need to finish up. So we built it bottom up. We did like terms, and then we moved up to atoms, and now we're going to move up to rules, and then we're going to finish off with program, which is probably going to be the easiest one. It's a collection of rules. There's not much to it. So let's jump into that, and then we'll I don't know what the agenda is here for TreeSitter bindings for Elixir. We'll just jump in where we are. I'll talk about NIFs, how you write them in Rust with rustler, and we'll get to extending what I have so far. So if this is your first time here, I'd love to see you say hi in the chat. If you have been here before, also say hi. I'd love to see people coming back. So thanks for joining me on your Sunday afternoon or evening. And apologies for the video. It's a little bit dark here today. We've been overcast for the past 3 days, and so there's not much ambient light. Cool. All right. So we are doing TreeSitter bindings for Elixir later. Let's look at Datalog. Okay, so where we were last time, we had we parsed variables and symbols, which were the two branches potentially of a term in Datalog. And remember, we're looking at, we want to parse this. Basically, this file, we want to parse it. and we want it to turn into the data structures that we created over here, right? Okay, so so we started with parsing var, so variables and symbols, and those roll up into terms. And then we had a term list, so this is what is used inside an atom. So an atom is a name, and then potentially parentheses and a list of terms. So that's what this provides. This is kind of a sub rule of atom. And then atom is basically anything that starts with a lowercase letter for the predicate symbol, and then it can be alphanumeric after that. And we're turning that, we parsed out just to satisfy the fact that this is going to be lowercase letter. And then we did, an optional of term list, which is surrounded by parentheses. And I think that, right, so one thing that's important to point out from where we were last time, we have this WS combinator, which is basically any amount of surrounding white space. And I just pulled this directly from the NOM documentation. It's kind of crazy with all these generics, but basically it lets us leave this inner thing that we want to parse, this inner parser, to be generic, and then we can surround it with any number of white space characters, including new lines and so forth. Okay, so our last step, our last two steps that is will be rules and then the program. And so, although we won't have a specific one for program, what we'll do is we'll probably do something here in parse, and yeah. So this is going to be the entry function for when we get a string that contains Datalog. We will we'll parse it here. Okay, so we did atom, and let's look at our test real quick. So this is the sort of test that we made last time. We were checking both atoms that have no arguments, that have no terms associated, and then also atoms that have arguments, and also checking that white space wrapping around it. Okay, so because we know what the syntax is, I kind of like to make a test first, and then we'll make the test pass. I don't usually do test-driven development, but this is a pretty easy way to do it. So what I'd love to do is say, let's list out what sort of examples we want to test here. So we want to say a rule with no body, and maybe there's a 1A, which is with no terms in the head. So basically similar to what we did up here. Okay, no body with no terms in the head. Okay, and then with terms in the head. Now this is we don't have a requirement until we start trying to evaluate that rules are range restricted. So we could potentially have a rule with no body that has variables in the head, which is kind of interesting. Okay, so then we say a rule with a body, and this would be with no terms in the head. So there's no reason why. I don't know the exact use case for it, but maybe we have a case where we don't have any variables, and it's just like you have this. Let's say you have something, and if this thing is true, or rather this single atom can be true if these other things are true, right? Okay, and then of course with terms in the head, and these are really just about like making sure we can parse all the things. Okay, so let's spec out what this one would look like. So we'll say expected. So this is going to be rule. And let's fill that out. So the head is going to be an atom. And so its predicate symbol should be, let's use like we did before, no args, right? ToString. And then the terms is going to be an empty vec. And there's no body. So the body, what is the type of body here? It is a vec of atoms, right? So we'll have an empty vec. And then we're going to say result, and we'll say rule, and we'll pass it no args dot. That's kind of interesting. So to distinguish a rule from an atom, so an atom doesn't have any terminator, but a rule always ends in a dot. Okay. And then let's do, okay, so then we're going to say, and this is going to be pretty Q expected result, right? And we'll do something very similar for the rest of these. Okay, and let's call this args no body, right? Okay, and this is args no body. And then let's give it some some args. So we're going to use symbols. In this case, they're strings, and it takes. So this we see this kind of rule already in our example. So it's stuff like advisor, Andrew Rice, Mistral, contrast, and dot, right? So that's a rule right there. Has no body, but it has arguments. Has terms in the head. Okay. So let's make this. We have to define what our expected is here. I'm going to put a return in here and let the formatter fix it for me later. So this is going to be term var or term sim a dot toString, and then we'll have term sim b dot toString. Okay. And the formatter made it good. Okay, so it's already complaining that we don't have this rule function defined, which is fine. Let's go ahead and fill out the rest of this test, and then we'll start writing this function rule. Okay, so rule with a body with no terms in the head. Okay, so we'll do something like this. Okay, so it has no args, and then it has a body of which is going to be an atom. Let's just fill out all those. So we need to make a predicate symbol. I don't know, let's say foo. Okay, so that would mean, in this case, this is like no args is true if foo can be unified. So no args is unified if foo is unified. Now we can put no terms in this body atom, or we could put a term. I'm going to put a term just for argument's sake. This is silly, but you know, I'm running out of names. Okay, so what does this look like? Let's copy this stuff, and we will look at what the text looks like. So this particular one would look like no args, and then we have the turnstile, and this would be foo and quote bar. Right? Dot. Okay, so this is saying if you can unify foo bar, then no args is unified. Okay, and then we are going to, so that's our third example for this, for rule parsing, and then Let's just copy this again, and we're going to say, let's say has args. Let's do it this way first, and that is foo of x. So here we're making a variable and we're using it in the body, making a free variable, and it's unified in the body. Okay, and I need to fix this because that's not a string. ToString. Honestly, I should probably just use format in these cases. Okay, so here we're going to say has args, right? And this is going to be a term var x ToString. Okay. And then here and this is not a symbol, this is a var in this case. Okay, so we have a body. The rule has args. And I think we need one more case, which is we have more than one, because this is a list, right? The body is a list of atoms. Yeah, I did have an atom macro. That's a good point. I was having trouble importing them from up here. Maybe we should try that. Yeah, let's take a brief break because I'm going to make the let's say this last example, and we'll see if we can get those macros in there with terms in the head, with multiple terms in the body and head. Okay, multiple terms in the head and multiple atoms in the body. Okay, so I think I might need to do, yeah, so this does use superstar. Let's say, can we use create star? Yeah, it's probably saying unused. Let's see, we might need to do macro use. The thing is, when I've had, yeah, only an extern crate. Yeah, it's not an extern crate. Whenever I've had to do this, it's like, so yeah, we use create stars up here, which should import everything from the parent, and then we also use super here, which should import everything from the so we should have that. Oops, we should have that macro available. Let's try it. So rule, bang. Okay. Let's look at what that macro does. So head, arrow to body. Okay. So we'll say atom has args, and then this is going to be var x, var y, right? And then we'll go, say let expected. And that will, how does that macro work? Okay, so it has any number of, right. Okay, so we'll go atom foo var x atom var. Thank you for suggesting this. We'll see if it works. Y. Cannot find macro rule in the scope. Yeah, this is the problem I ran into last time. Maybe, do you do that? I forget. Right. All right, let's look at the documentation real quick. Macro rules. That's not what I wanted. I probably need to do this. And then let's go put it on all the others. All right. Hey, it's no longer complaining. Thank you for suggesting that, Isaac Dynamo. That was great. Okay, I'm gonna put some new lines in here just to make it a little bit easier to read. Okay, so that is our rule, and then we'll do result rule, and let's make that in actual Datalog. Has args, takes x and y, turnstile, foo of x, bar of y, dot, unwrap. Okay, and then we'll do another assert EQ, expected result. Okay, so now it's just complaining that it doesn't find this function, right? Okay. So let's go up and write that function. Honestly, I want to move the white space thingy down because it's kind of a utility function. Okay, so what do we know about what a rule looks like? We're going to take texter. Excuse me, this is going to return an iResult. Remember that iResults in NOM they always return the remainder of the text, the input text, right? Or input buffer if you're using bytewise stuff. And this is basically result where the return type is a tuple of these two things. Okay, so what we're going to do is we're going to say, well, there needs to be a head, right? And that's going to be an atom. An atom of text. And I'll put a question mark there. So if it finds an atom, and then what we want to find is we want to find the turnstile. Okay, so actually there's a couple options here. Let me hang back just a second. Yeah. So what we want is an optional. So this is optional. And we're going to have in sequence, let's see here. I'm gonna have to look at the NOM documentation again, because I forget their combinators really quickly. Okay, so just a pair, yeah, so honestly, it's probably what we want to do is preceded, right? Okay. Now we could potentially yeah, because I think we want the turnstile character only if there's a body, right? Only if there's a body. So let's look back over here. Okay, so we want something white space tag. There's the turnstile. So any number of white space. We want pair. Okay, I didn't import that. Sequence. Was it sequence? Yeah, preceded. So let's add that. Preceded. Okay, we want preceded. And here's the other thing. I think we should do white space of atom like that. So this is like any amount of white space around it. And then here, preceded, we want white space around that turnstile. And then we want a delimited list, right? So what does that look like? Okay, we want not sequence. Honestly, sometimes the names of these is multi. Yeah, multi-separated list. So here's the thing. If we have the turnstile, it should not come with a dot right after. So we need to have at least one atom, right? Okay. So now I feel like I'm about to do some things that are kind of pessimal because we did white space, wrapping tags. So we're going to need to be careful here. Separated list 0, except we're going to use 1. So we want at least 1, right? So what we're going to do here is do the tag of comma and then white space surrounding atoms. That way they can come, the white space can come between the atom and the ending period. Or it can come before it, between the, and actually that makes me think that this doesn't need the white space combinator on it, because we have white space potentially surrounding this atom that'll get all consumed, then tag, and then we're putting white space around these atoms, so we don't need it on either of these static strings that we're looking for, right? Okay, so this will be body. Let's see. Okay. Oh, right. We actually need to pass it the text. Okay. So now this is an option of a vec of atom, which is nice because we can do like what we did down here, which is unwrap or default. And then finally, we want, and we don't care what it is, we'll say tag of dot text. And that's just to make sure we consume the dot at the end of the rule. And I'm not going to put white space around that last one, because note that we have it around this, and we have it around the head. And I'm tempted to put it around rule when we go to parse program. Okay, so now I think we have the pieces. So we see that head is an atom, body is an option of vec of atoms. So so here what we're going to do is we're going to say this is, we have the remaining text. I actually want to, so we have the head and we have the body, which is body.unwrap or default. That was pretty easy. I thought it was going to be hard. Okay, what's wrong here? Oh, I need the question mark. Yep. So that's just to make sure that if this does not pass, it returns, hey, I expected dot and didn't get it. Okay, that was not so bad. I really kind of love NOM for this sort of thing. Yeah, I think it really lets you express these parsing rules pretty straightforwardly, which is nice. All right, let's run these tests. Not mix, cargo test. Okay, so it's warning about those things. All right, so this was our test, and let's just test parsing, right? Okay, so our rule thing passed. Let's see if we can do any other other things to, let's exercise the white space a little bit, right? Make it kind of weird. Okay, so that's going to be a little bit strange, but it should still pass. Yeah, yeah. So I think our white space is probably okay there. And let's wrap it up. Let's wrap it up. And we will have, I think we already wrote a test down here, right? Right, so this is what we're testing the entire module. So the last thing we need to do is go here in our parse function and parse programs. So this should be fairly straightforward. So let's say text program is going to be honestly, it's just a many, right? The many zero. Yep. Non-multi many zero. And we have many zero here. So we'll say many zero, white space surrounding rule. And then we'll say program. Let's call this rules, just to be clear. And no, this is going to be a vec of rules. So we just put rules in there. And we're done. Let's see if that that example parses, and then we'll play with this file and see if we can break the parsing, and then we'll move on. This hasn't taken too long. I knew, like, when we left it last time, we did about an hour on it, and we did the hard parts, and this high level stuff is way easier. Okay, let's just run the whole crate. Okay, so the example failed. That's unintentional. We're trying to get that to print out. I may just comment out that test. But you can see here that test parses Datalog. Okay. Let's focus that test specifically. And then and let's play with that example file. So I'm going to throw some junk in here that should make it be a little bit yeah, I know that feeling, Isaac Dynamo. Yeah, what I found was, and this is mostly from doing the advent of code with NOM, was that sometimes you just kind of you can't make one, you know, uber expression. And in fact, we could probably go back in here and like make some of this a little bit simpler. But yeah, I think this is pretty good. The main thing is, like, you got to put question marks a lot. That is a really good point. Thank you for sharing. And we're just gonna throw some junk in here, and we'll save that, and let's see if it still parses. Yeah, it's still, so it is white space insensitive in a way, in the way that we want, and that's good. Now I would say that NOM is probably it has the potential weaknesses of all parser combinator libraries over parser generator libraries, or in contrast to. So, like, you need to be careful about not creating pathological repetition cases, pathological or issues with greediness, because it is greedy. Like, it's by default greedy. On those combinators, so you have to be really careful, and that's why I was like, do we want to put the white space around these things? And I tried to be, you know, look at, because if we put the white space here and the white space around this and the white space around everything, then you're going to spend a lot of time trying to potentially match white space in places it's not going to occur. And since it's greedy, you know, what does this combinator do? Let's look at it again. Right, it's this parser you give it, delimited by any number of spaces, 0 or more. these two combinators, they're the same one. Sorry, this combinator is greedy. So it's going to try to consume as much white space as possible. Which means that, you know, there was really not a point to putting it around everything. Some of those things will just fail. And what would be more likely would be that you would tend to consume things before the next concrete item that you're trying to parse, and then if you wrap that thing with white space, it wouldn't have any on the front, but it would consume everything that follows it, which I guess is okay too. But it's just strictly not necessarily to be paranoid about it. We got it in the places that matters. That end of rant. Okay. So let's look at what we have to commit here. That's pretty good. Okay. So we're going to add the... And I also did add a license to this. I realized I hadn't. We'll make that in a separate commit. Okay, so there's our kind of messed up example. We added macro exports for our fun macros that make it easier to write. We implemented the rest of the parser. And we got tests. So let's make a commit. Finish parsing the entire AST and tests. Okay. I want to let's make the... I have a README here. It has no contents. And what I want to do is make it, not that. Use this window. I have this. And we'll just like copy there. Let's README. Can I view raw, please? Yep. I'll just copy this for sentence. And I think that should be enough. Yes, I will add the links to the VODs in the README. That would be a great thing to do. Thank you for the suggestion. Okay. In Rust. This implementation was coded on my Twitch stream. You can watch the videos of this here. And I will link to, real quickly, what's an easy way? Let me see. Let's go to my channel real quick. I'm just going to link to the playlist. Yeah, that'll do. Okay. Sorry. Yep. There we go. And let's, let me say video, the recordings of those sessions on YouTube. We'll make that an actual link. Right? Okay, and then we'll link to my Twitch stream. All right, twitch.tv, Shemika's code. Okay, so that's pretty good. And then this project is basically done. I think that we could do some things that are, you know, more advanced later. I just wanted it to be you know, basically the equivalent of what we did in Elixir over a year ago. So maybe it was 2 years ago. Geez, time has flown. Okay, so we're going to add license and readme, and add license readme with links and license, and then we can move on. Let's push. Cool. All right, I think that was pretty successful. I lost my Emacs buffer. There we go. So we parse, we have macros, we can print them out, we have range restriction, and I think we're good on this. Okay, so let's talk about tree sitter. So it's probably worth bringing up, because I've done quite a bit of work on this already, just because I was excited about it. It's worth bringing up what tree sitter is, and you can go to this website, treesitter.github.io, and yeah, it is a parser generator tool. So what that means is, and here's the fun thing about it, I think, is that you don't have to... If someone has written a grammar for tree sitter for some language, you can see that these are the language bindings. See, these are the parsers. So there's a ton of parsers here. That's over 100 probably right there. You don't have to worry about building the parser yourself in order to use it, which I think is really, this is a subtle thing, but I think it's really different than a lot of other kinds of libraries where maybe what you have to do is pull down the grammar, and then that grammar generates a parser into your own code base. Now this, you can just pull in a REST crate that contains the grammar, which is like, I think that's awesome. And now I know that's not strictly true. You know, I did years ago work on a packrat parser generator, which didn't quite work correctly because I was young and naive. But in that, what you could do is use the parser generator as a library, give it the grammar, and it would generate an Erlang module for you. And that Erlang module, you know, kind of conformed to the sorts of things you expect out of Leaks and Yek, the parser generator stuff for Erlang. So you could give it a file, or you could give it you know, a string, a char list, or a binary, and it would, you know, attempt to parse it. I think that this is great because it's, the parser generator toolkit is generic. So one of the big powers of it is that you can have like a multi-language document. You can take say, let's take Elixir and like ERB EJS, which is basically EEX, and you could hook those together, and you could have a parser that handles both Elixir between the template tags, and then the outer part, and you could combine that with HTML to get a parser for the tags that you're putting in the page. So like, this is kind of bonkers. Anyway, so pretty exciting. It's also really robust. It doesn't just blow up. It has really sophisticated error recovery. So if you have a syntax error in the middle, it doesn't necessarily mean that it won't parse the rest of the file, which is pretty cool. Okay, so that's not what I wanted to do. Let's go over here. So I just made a repository today to hold this stuff. And I think, yeah, let's, arc is being a pain for me. Let's just go to shank ribs, X tree setter. Okay. So making that as a new tab, and then I'm going to favorite it. Today pinned. Okay. Cool. So the other thing is, you know, Mitch wanted this as something he could use inside Next.ls. So what we're going to do is we're going to try to get as much as possible in here that he can use to manipulate syntax trees inside the language server. I don't know exactly what he needs, so we're just going to be trying to get as much as the APIs make sense at first, and then we will go in and you know, when he gets me some feedback, we'll add some stuff. Okay, so quick overview what the repository looks like. You make a new Rustler project, so basically make a new mix project, and then you add the Rustler dependency. You say runtime false because it doesn't need to be there at runtime. It's just for like handling the native compilation. And you say mix rustler.new, and you tell it the name of the crate that you want to create it. Mine was called X tree sitter because that's kind of the convention that the bindings take. And I didn't want to conflict with anything else that might be out there on crates.io. Now, it doesn't really make sense to compile this this crate outside of the binding itself, but that's sort of the structure that we're in. Okay, so it generates a project for you, and then you know, it adds Rustler, and I specified a particular version of the NIF, which means that this will only work on OTP 24 or later, if I recall correctly. But I don't actually care yet. We'll see. I don't know what sorts of versions that Mitch needs to support. Okay, and then let's look at this cargo tunnel because it's a little bit crazy. Everything up here was generated by the Rustler generator. I added these features, and this is so that you could choose at compile time which additional languages you want. So like, I know he has to parse Elixir. I suspected that if people are doing, you know, web projects with Phoenix or something like that, they're going to want like CSS, and they're going to want JSON and SQL and HTML and JavaScript and TypeScript and these things. Okay. Potentially because these might be inside Elixir files in short snippets, or, you know, the Elixir might be, you might be doing EEX, right? Like embedded template like this, and you might have that inside some other kind of file. But by default, we're only going to use the Elixir parser. And so what this does is this says, this turns on the Elixir feature by default. The Elixir feature implies that we are turning on this dependency tree sitter Elixir. And just for fun, I added Gleam because Gleam is cool. Okay, and so all of these parsers are optional dependencies. And then we need the build dependency of CC for tree sitter. Okay, so that's basically the overview of what we've got so far in there. Let's start looking at the code. And I think that we'll start with the Elixir code because there's really nothing there. So there's an empty tree sitter module here. We're going to make some other modules that do like define structs that we'll expose, that'll be useful. And then there's the module that implements the NIF. And you may have seen this earlier when I started the stream. It is completely boilerplate. And one of the things I learned in the last year or so, making bindings of a complicated Rust application to WebAssembly was that, and like to be consumed by an application, a large application written in TypeScript, was that you don't want to expose the exact same interface on both sides. Because then it's like, well, why didn't you just write it in one language or the other? So what we tend to do, and the pattern that I'm going to follow here, is write a very simple functional interface. And I mean just like things that take arguments and return values, right? We're not talking about types that are directly bound. In fact, you can't even do that on the beam. There's always some kind of indirection there. So we're going to make this like just functions in a module type of interface. And what we'll do on the outside is wrap those into something more useful. So we might have, say, like there's a parser module, and it'll take a struct that is a parser, and then maybe it'll be like you try to parse this binary, right? And that will call into something in this module, which is like parser underscore parse or something like that. And all of these will just have this Erlang NIF error NIF not loaded. So this implies that where the code for this function is going to come from is in the native definition. So in the Rust code. Okay. Okay, so let's look at that entry point, and then we'll get started poking at it some more. So I've already started doing some of this. Some of it is not correct. We're going to have to redo some of it, mostly around resources, and we'll talk about what those are. So I'm just importing rustler up at the top here. It's got some attribute macros for functions, which this is like this is so much simpler than writing NIFs in C. Oh my gosh. You just say, hey, this is a NIF. And this is a NIF, and that does some things, that generates some code for you. And then, we have a load function. And then down here at the bottom, you say init. This is the sort of thing that you would do if you're writing one in C or C++. There was a macro, I think, that defined a function that had a particular name that Erlang VM expects to find. This kind of does that same sort of thing. But basically you're giving it what is the name of the module where you want these functions injected, what is the list of functions, and then I think this is incorrect. I think I need to do colon like that. We'll see. It was working earlier. I'm not sure why, but I was looking at the definition of the macros. I'm like, there's no way that works. Yeah, let's just leave it. Okay, so this is saying we're defining some functions for this module, and when you load this library, you need to run this function. And that function takes the env. So the env is sort of like the handle into the Erlang VM, which lets you allocate Erlang types. It's sort of your little window from your NIF into what's running right now. And one of the things that I did is, I'm delegating because I want the parser to define some things that it needs to define at startup. But the parser module, excuse me. But I also wanted to say, let's use Erlang's allocators. So it doesn't have a calloc. So that's what this none is here. There's no calloc for in the NIF library. But luckily that's optional for tree sitter. Basically calloc is an optimized version of calling alloc n times. So it's not strictly necessary. Let me turn that off. And then of course it has realloc and free. So we've set up the allocator for tree sitter. And this is probably why this is unsafe, is probably under the hood doing something like setting the value of a static. So that's why this has unsafe around it. Otherwise, I probably wouldn't need it. Okay, so here's our two interface functions. So this is Let's look at language. This is really just me thinking about what would I want this interface to look like if I were using it myself. And some of it was that I want to pass, when I want to create a parser, I just want to pass an atom that represents the language that I want that parser to be for, right? And then I need to be able to check potentially and, crash or something if that language is not installed or not supported. So this was just a first attempt of what's something easy I can write in an if. So here it is interpreting the input, and this comes down to some of Rustler's macros, but which we'll look at that file in a second. It's interpreting this input, which is an Erlang term, as this value, as that type, and then I can call a method on it because that I impl something on language, right? So is that supported? Excuse me. Let's look at that file. Okay, so here we use Rustler again, and I have this enum language, and these are basically like, this is some boilerplate stuff. I really didn't like writing this file. But basically I wanted to represent all the languages that I potentially could initialize a parser for. And then whether they're supported comes down to whether their individual features are turned on, right? So it's a simple enum. This NIF unit enum does the work, the derive there does the work of converting an Erlang term into this one of these values. Okay, so supported is the individual feature turned on. And then get language is like, give me the actual tree sitter language for this language I've requested. And then I did some macro down here that's like, okay, implement this for me. And it's really just comes down to, this is the name of the function I want it to create. This is the name of the feature. And this is the call you do to get that. And this is really just to get away from writing this out manually. And you basically implement it twice, one with the feature on, one with the feature off. Feature off, it returns none, right? Feature on, it returns some, and then it calls that expression. So, and then I just did this for all the languages that we have available in here. Okay. Luckily, I thought I could have done something a little bit more clever, because they're basically all like, hey, there's a top level function in this crate called language, and it gives you back the tree sitter language for that language. Okay. So remember, this language it's kind of like the grammar. It's basically a reification of the grammar. Okay. So that's this. And then the parser new, we need to talk about the parser because I think this is not correct. But what you can see here is we're trying to create a new parser for the given language. Now this is our enum that we just saw. And then it should return a result. So this would be like, if you call it, it's going to return okay and the parser, hopefully. Or it's going to return error and then some error, right? So let's look at this. So we say this is the enum we saw before. So get language, and I'm going to turn on. That's not going to work for whatever reason. When I'm running two language servers in the same project, it gets messed up. Okay, so this is going to return option of the tree sitter language, right? This is the method we just saw. So I'm calling OK or on it, and if it doesn't return some and the parser, then it's going to turn this into a result where the error term is this. The error type is this. It contains this atom. And then I made some stuff here because I knew that I wanted to be able to use this NIF result type. I made some extension traits. We'll look at that in a second. But basically this just says, well, turn whatever this thing is into an error that's basically the same as the NIF result error type. And then we're, you're using the question mark operator to either return that error or just give back the inner value of the OK. Okay, and then we're creating a new parser, and we're passing the language, and then we are wrapping that in a resource arc if it succeeds. Otherwise, we're converting the error. Okay, and this resource arc thing, man, I don't even know if we need it. I'm not convinced yet. The other thing is, it's not clear to me because the old way, I don't remember when this changed, but the old way was you had your resources are inside an arc mutex, which is what I would kind of expect with this sort of code. But you can't put a mutex inside this resource arc thing. So I'm not sure what that restricts us from doing. But we'll see. Okay, so yeah, let's look at this real quick. This is a trick you can do if you're trying to add things to types that are both from another crate. You make extension traits. So I just basically said I want something that converts any other value into any, for what I define, into this rustler error. And I think it's worth looking at the documentation for this real quick. Rustler. That's close enough. We'll go to docs.rs. Yeah. Okay. So its error type, and I should probably just qualify that. It has a number of different things. So if you can give bad arg, which raises a bad argument exception in the Erlang VM. You can take this string and turn it into an atom, and that's the return value. So you might do something like return undefined or return nil. You can raise the atom, which actually is an exception, so like an exit or a raise in the Elixir sense. So you might do this with, like, if you have an exception module or something, you might do that. Raise term is basically any term that's not an atom, and it has this encoder trait. This encoder trait it turns Rust types into terms, Erlang terms. And you can define this yourself, but I haven't had to yet. And then term is just like return, okay or error, right? So like error term, right? And so that's what we were doing over here. Is we're saying we want this to return error unsupported language as an atom. And there's this module. This doesn't need to be its own file, but I did it anyway just in case. This macro defines some atoms at load time. So unsupported language is one of those that I wanted to make, and then it defines a function. You can just do that. Okay, so I implemented into NIF error for atom, which is basically just box it up, right? Because atom is something defined by Rustler. It already implements encoder, so you don't need to do anything. You just box it. And then the same for, so we also did it for language error, because we saw here this could return error with language error, which we'll look at that implementation again in a minute, I promise. So I was like, well, let's just format that thing into a string. Strings can, encode to binaries or charless. I'm pretty sure they encode to binaries because of UTF-8. And then that just becomes the result of our error tuple. Okay. And then this, this trait with NIF error, I implement it generically over any result where the error type implements into NIF error, and then it returns a NIF result. So, it's not it's not complicated. And yeah. let's go into the parser file. And I think this is where we need to do the most work today. Okay, so this one, we have a parser. It's just a wrapper struct. It's just a new type, basically, around the tree sitter parser. And we're doing this so that we can turn it into a resource. So like if we tried to do resource on tree sitter parser, it'd go, you can't do that. Sorry. Because of the orphan rule, right? So in this case, we're making a new one, and then we're trying to set the language on it. And here's where that error can come from. Is set language might return an error. Like that language is poorly defined. I'm not expecting that to happen, but like the type system makes me account for it. I could potentially panic there, but like that's not a really good thing to do in a NIF. If you panic, you're kind of crashing your VM. That's not nice. Try not to panic. And then if it succeeds, we return, self-wrapping that parser. Okay, and so this is why we have in the parent module, we have this load function. It calls parser load, right? And so that means that at load time for this dynamic library, this will be called, it'll register a resource type. It might be fun to, I don't know if we can go in there and cargo expand it. Let's see. Nightly expand. Let's just expand the whole doodad. And that did not work well because by syntax coloring on my command line. I wonder if I can do like no color. Color never? Is that what it is? Okay. Yeah. So you can see here, it generated some stuff. So it generated this NIF function, which is exposed to C, and this is what the runtime will load. It will call. And yeah. Yeah, it looks like it's setting some statics on the module. Pretty crazy stuff. So here's my function that I wrote. And it's probably going to do right. So it's calling my function down here, my load function. Okay. And what did I want to see? I wanted to see. This is fun. Parser new. Let's go see the. I wanted to do parser. Okay, so this is what I wanted to generate. So this load function, this is what it generates for the parser type. Let's see if we can figure this out. Okay, so it has a kind of a descriptor for this type. It starts as none. And then let's see. And then it calls this open struct resource type, which calls some of the NIF functions. To register this type, you have to give it a name. Note it has to be 0 terminated because C strings. And then, right, so this is, you can create it at runtime, this resource, and then if it fails, it prints, failure creating resource type. Not that useful, but, and then it sets that static. If it's created here, it sets that static, and then it implements this resource type provider thing for this type, which just gets that static value out for you. Kind of complicated code, but like this is the sort of stuff that you would have to do quasi-manually in writing a CNIF that Rustler makes really nice for you. You can see that my code there is just little baby code. Okay. I'm gonna look at the Rust bindings. That's not what I want. So Isaac Dynamo says a bit of an outdated comment, but I think the function is marked unsafe because the programmer must guarantee that they provided alloc-free and etc callbacks have the expected behavior. They're referring to the bit where I set the allocator for tree sitter. So like that's something that would be set on startup for most Rust programs. Okay, yeah. It might be good to go in here, see if it'll do that. No, it's not because the Rust analyzer is not working right. Yeah, I could also see that if this is like a global static thing in the binary, and you want to replace those functions from the perspective of, from Rust perspective, that's unsafe because static shouldn't be mutable from Rust perspective. If they are mutable, you have to say, hey, I know what I'm doing, which is basically what the unsafe block does, right? So that's a good point. Thank you. Okay. So let's look at the docs for tree sitter. I was hoping that this would just jump me to the docs.rs, but it wasn't. Okay. So it has a parser type here. This is what we're working with underneath. You already saw the set language we were using. The next thing I'd like to expose is parse, and this will be really interesting. So I think just before we get going on that, I want to show you that this is actually working. So, excuse me. Let's clean, just to be clear. Have a clean conscience. Compile. It's compiling my NIF in release mode, by the way. So it does do the full optimization passes. All right. And let's call language supported Elixir. So this is calling into a NIF. You can see it says true there. Let's say, hey, is CSS supported? Nope. So that's all that work I did with the features. So we can say and this is, I think I had some bugs here. So let's say parser new, let's say p Elixir. Right? Okay, so I got a reference. That reference is sort of a magical VM thing. It doesn't say that this is a parser, and this is one thing I want to fix with that API. But if we try to make a new one with CSS, it should, yeah, see, it returns error unsupported language. What I would prefer it have done is say okay and that reference. And I'm not certain how you do that if what I was doing before was not correct. So if anyone knows what to do with Rustler there, let me know. Because I would love for it to return the tuple okay. And I don't know why it's doing that. Okay. Yeah, so let's look at that. Okay, so let's make a function that kind of exposes this, or maybe we'll do deref. We'll implement deref. There's a couple challenges here, though. I think we probably will need to make functions for everything that we want to expose, because this tree needs to be a resource too, probably. And partly because it's got some goop in it that we can't send to Erlang or Elixir, right? It's not really clean. Um, so yeah, so let's go ahead and make that. Okay, and then we'll do resource tree env, and then we got that set up as a resource as well. So then we can do something like parse, and let's see what this takes. The issue I have here is this takes mute self, and this is probably going to come back to bite us. But we're just gonna roll with it for now. And this takes, let's just copy this. We're not gonna pass the old tree for now. We'll do a simple parse one, and then we'll say option tree, right? And this will be text. Is that what it is? Yep. Okay. So then we'll say self.0 parse text none, and we'll map it to our own tree type. So to be clear, parse returns option. You call map on it. You can pass any function. Constructors are functions, and so we are just wrapping it in our own tree type there. Now, obviously, we need to be doing some interesting things with trees themselves, so we'll have to start to work with those. But let's see if we can make this work. So now we need to make an interface function. And here's where it could get interesting. So we want to do the parser is going to be probably a resource arc, a parser. And I don't really know how we get inside that to make it mutable. And the text is probably going to be a binary. So let's look at Rustler's documentation. Types, binary. And we can get as slice from that. So that'll make it nice. Okay. So let's say this text is binary. And this is going to return an option of parser tree. Right? No, let's do, I think this needs to be in a resource arc as well. Because I really don't know if you can pass those things back directly. Now, we could potentially comment out this line, and the type checking should fail, but we could see if you can pass that back directly. Anyway, okay, so we need to figure out how. Let's just say bytes is text as slice, because we know that we need to do that. Let's add this down here. Parser parse. And then yeah, let's look at resource arc, because again, I'm not confident about oh, okay. So we do need mutex or read-write lock. The problem is I don't know if this is implemented for those types. Encoder is not. And remember there was that thing that when we did the cargo expand in here, oh, I cleared it out. It implemented that resource type thingy. It's in this module, right? It implemented this for us, resource type provider. I don't think that it's implemented for mutexes of things. Unless someone knows. Right. And I'm kind of worried about that. Yeah, because note that this is like an arc, but the contents of it are a resource, a NIF resource. If you're not clear what I mean when I say resource, resource is just like, to NIFs, this is, hey, I have my own struct that I'm going to interpret, but you should just treat it as, you know, as a contiguous section of memory, and not care about what it is. But then the Erlang VM will manage based on when you say keep resource or release resource or create resource. It will allocate space for it and then manage the lifetime of that object. So this resource arc just says you can pass this around to other processes, and it'll be safe. And I think that's not what we need. Yeah. Excuse me. This is the macro we were looking at earlier that generated. Okay, well, let's just, based on what it says here, you sync mutex or read write lock. I think we should just try wrapping it in one of those and see what happens. See if the compiler complains. Okay, so in here, let's use standard sync. Let's try mutex. It's the more conservative one. If we need to later, we can switch it to a read write lock. And then, and that way, what we can do here, instead of resource arc, we have mutex. And let's see real quick before we go any farther with this function, whether resource arc is appropriate for tree, because if it allows mutability, then we need to put a mutex on it. If it doesn't, then we can put it inside an arc. Okay, so tree, you can do edits to it, right? That might be worth putting in a mutex. Yeah, that's the only one that I really would be concerned about. Okay. So, yep, let's put it in a mutex. Not fun, but... So this returns option tree, right? Okay. So we've got a mutex. Let's lock it. Acquires a lock, locking until the current thread is able to do so. Okay. That's the other thing, is we might need arc mutex. Okay, so here's a the lock result could return a poison error. It's either going to return the guard, which is basically the wrapper around our object, or it's going to return a poison error. Yeah. So I think that what we'll do here is like what we did for that language error from tree sitter. We'll make into NIF error, and we're gonna have to do T into NIF error for standard sync. Oops, it was in here. Standard sync poison error. And we'll do similar to what we did for language error and just format it. Because it's really about reporting the errors into Elixir. So this is where Rust Analyzer would help me a lot. I might restart this workspace with just just this space available, but we'll see. Let's just do that. Okay. So we've got that defined. Okay. Don't need that. Oh, by the way, yeah, that's actually one thing I skipped at the beginning. A nice thing is you can say config tree sitter NIF and tell it the features that you want, and it'll turn those features on the crate that's being compiled inside the native folder. So if we wanted to turn on, say, like Erlang or you know, embedded templates or something like that, we could do it right there. Okay, let's see here. Okay, so now we want to I believe it's try-lock. So I don't work with mutexes that often. Mutex. So try-lock could return, or is it just lock? Or unlock, lock. This is interesting. Shouldn't be a problem, but that's a good question. Are NIFs always run on multiple threads, or can you pin to a single thread? The short answer is they are run on the scheduler thread. So it's not, they will run on the thread that owns or is currently running the process that makes the call. So it is incredibly important, and this is something we'll do with our NIF function, I think. It's incredibly important that you be conservative about what you do inside a NIF. It should return like within a millisecond, or you run the risk of messing up the scheduler's timing. So if we were going to do any, and like I think parsing is good enough one to do this on, because we don't know how long that's going to take. We don't know if it's going to be under a millisecond, or if we're passing it like a 1 gigabyte binary. So I think it's worth running that. Now it has the Beam has specialized threads for things that are long running that should not block the scheduler. So basically what will happen is when it makes that call, it'll dispatch it to a worker thread in what's called the dirty pool. It's either IO or CPU bound. And those are really just so that like you can distinguish the tasks and not, you know, throw all these CPU bound things at IO threads. Anyway, but how's I going with that? So what you can do then is it'll suspend that process, waiting for the reply from the dirty CPU or dirty IO thread. So, and that the size of that pool is configurable. I think it has a pretty reasonable default, and they tend to be more idle than the scheduler threads. So they're really like, you want to do some big IO or you want to do some big CPU task in native code, run it on that, on one of those separate threads, and then you don't block the Erlang processes from continuing about their work on the scheduler threads. But if it's something like you know, our language supported function, yeah, that's going to return really fast because there's not much to it. You could almost inline this thing, but that will return pretty confidently within a tick of the scheduler. So there are other tricky things you can do. From inside your NIF, you can tell the scheduler, hey, I consumed this many time slices. But I think that has fallen out of favor, mostly because it's hard to measure that. And then also just like dirty CPU and dirty IO threads make it so much easier. So I actually want to do that on here, but let's get it written first. It was a great question, Isaac. Thank you. Okay, so we're going to call parse. So we were talking about which, should we use lock or should we use try-lock? Let's look at try-lock result. Try-lock error. Okay, so that's just so if you want to not block. And I think since we're going to since this is accessing the mutex, right? We're going to put this on a dirty CPU thread. And I need to look at how to do that. Dirty CPU. Then it's okay to block this thread. Because if we block this thread waiting on mutex and it was a scheduler thread, that would be really bad. Okay, so we'll do lock. And then we want to do question mark there because that will return. No, we want to do with NIF error. Right, and then question mark. If you could pin, yeah, the thing is though, if I could pin, then you say, so the question is, if you could pin, then you could use ref cell instead of mutex, but I think mutex is a better option in this case. Yeah, you could pin, but then you're saying any process that accesses this thing needs to always be on that thread, and I don't think that that's something that you can reasonably assume inside the beam. So mutex it is. One thing that's funny is, and I don't know if I talked about this earlier, but the beam has its own concurrency primitives that you can access from NIFs too. And it has its own async IO stuff. So like it has poll and select and whatnot. And none of that is exposed to Rustler. So one downside of using this mutex is that you don't get, like the Beam VM does a lot of accounting about its own lock usage, and we're not using its locks here, so you don't get this tracked. Kind of a just a thing we need to deal with. Okay, so we were implementing parse. Yeah, so we get, and then we convert the error and we try to turn it. So this should be something that derefs to parser, and then we'll call parse, and we'll pass it the text or the bytes, right? Bytes as a slice. And then we'll map that So that returns an option, right? So we'll map that to mutex new. Boy, isn't that a statement. Okay, the question is, isn't there an async message between the caller and the NIF, or is it really just a function call? No, it is literally a function call. So you can think of the built-in functions in the Erlang module, or basically in Elixir, the things that the kernel delegates to the Erlang module. Those are basically NIFs. They're called BIFs, built-in functions, but they're basically NIFs. And they have very tight time bounds on them too. So it is literally... And also, if you look into what the VM, how the VM is structured, its strategy for interpreting code or executing code is direct threading. Yeah, blocking is definitely a no-go. It does direct threading. So when you call something, it's basically a jump to where that code is defined. So in the case of calling these functions, it's like, hey, I'm going to jump to something that does a stack manipulation and calls that function. There's no accounting on anything. This is like danger zone. There's no accounting on anything that's inside a NIF. So yeah, here we are. We definitely need that dirty CPU flag because this parse of bytes may take a long time. So let's look at how to do that with rustler. And I think it's here, the NIF macro. Right, so we can say schedule dirty CPU, dirty IO. And that's a good thing to read if you want to know more about those. So we're gonna throw that in here on this one because we know that parse could take a long time. Okay, we remove that to do. Now, I don't know if this is going to compile, so let's find out. And we're probably going to get a bunch of Rust errors. Okay, let's find out what's going on. T is NIF returnable. Okay, so let's go back up here to the top. NIF returnable is not implemented for result mutex. Let's find that trait. That's not a trait. Why do you hide things from me that I need to understand? Is it in here? NIF returnable. Nope. They're not documenting it. Okay. So it's implemented for T, but it doesn't say what the bounds on that T are. Oh, T is just NIF returnable. Okay, so yeah, let's find. Oh, not Rustler Cogen. Rustler. Look at the source. I really hate that I have to dig into the source for this, but I think that's our only... Okay, NIF returnable is from Cogen runtime. Okay. NIF returnable for T, where T implements encoder, right? So, and then it's for result where T implements NIF returnable. So if T implements encoder, and that's all unsafe. It takes the env, right? Okay. So this used to be straightforward. Let's try arcmutex. I don't know that this is going to solve it because the other day I was looking through the code of rustler and I'm not seeing any references to these sync primitives. And because of the orphan rule, we won't be able to implement a resource for arcmutex of a resource. And that troubles me. And we'll but we're going to try it because this is the typical recommended way. And I don't think this is going to work. It's going to complain about the same stuff. Yeah, it's not implemented. Oh boy. Now, potentially what we could do is rather than doing it here, we can do this. And I think that's probably what we'll need to do. I hate it. Thanks, I hate it. Yeah, I'm pretty certain we're going to have to put it inside because then it's about the resource is this outer thing, and then inside it we have an arcmutex. I think that's what we've got to do. And maybe we don't need the arc yet, but we're gonna do it. Sorry, we'll fix that in a second. Okay. This is the arc, new, mutex, new. Let's get all the parens there. That sucks. Okay, and then here we need to do self dot zero dot lock parse map tree, and let's do tree new, and then that way we can do arcmutex there too. My has a sad. New, and this is going to take a tree sitter tree. This is going to return self. This is just this. Easier when you type it for the first time than when if you're trying to add it later. Okay. Yeah, that sucks. Let's so then up here I can get rid of this sync goop. And we can say this is a parser. And then this is a tree, option of a tree. And then we don't need to lock that. Oh, but we need to deal with that over here, right? So this needs to be okay. No. My brain's getting twisted. And we'll need to wrap up soon. Let me just rewrite this stuff. Okay, so if we get the lock, We get a result. We can call I think we want to call OK. It returns it, or changes it into an option. Yeah, so that gets us the inner parser, right? And then we'll say, I think we want and then on option, and then, right, because we want to turn, so we have the and then, and here's the parser, and we say p.parse text none, because we don't care about the old tree, and this is going to return an option of a tree sitter tree, and then we'll map tree new. Whew, another tongue twister. Okay. So we basically given up and turned over to interior immutability completely here. Thanks. I hate it. Okay, so here, now that this is it's internal, we don't have to do this. And we don't have to do this. And let's inline that. Okay. Now let's see if we can appease the compiler. Okay, so syntax error. I left on an extra angle bracket. Okay, let's have a look at what it's complaining about now. Did I not? Oh, yeah, I need to fix this. We don't need to do that, right? Because it okay, let's look up here. What did I do wrong? Yep, that's what I wanted. Okay, simple mistake. We're breaking them down. Okay, so NIF returnable is not implemented for parser. Oh, I see. So what they're saying here, I'm guessing, is that you can't return a resource directly. And that makes sense. So I think we're going to back some of this out. This is going to be just mutex, because we only care about the interior mutability here. We don't care about the sharing. And we'll do the same here. And then we'll put the resource arc around on the outside. And I think that'll do it. So here, this will be resource arc of that. And we'll need to put that map in again. Because the tree is the resource ultimately. And that means this needs to be a resource arc here. And right, yep. And because of deref, it will call this, and this doesn't need to be mutable because we lock. Okay. I'm probably still missing something. All right. So we're not using arc, no big deal. Option resource arc, expected option resource arc parser tree because return type. Oh, right. Okay. So here we need to map resource arc new. And then we just need to remove that unused import. And I think we'll be good unless it discovers something new. Okay. Right. Yes. So we just need to match that. Okay. The unknown function not found, parser parse. Yeah. Okay. So here's where we actually got to a binding issue. Question, can you explain the locking primitives? Are they for Rust threads or for the Beam threads, or does Rustler merge these such that if it's threads safe in Rust, it's thread safe on the Beam? That's a really nuanced question, actually. The locking primitives are locking primitives. You could use potentially the NIF ones that it exposes. But what they're not getting you, which the Rust primitives are, the Rust, standard library stuff is, this is giving you release the lock on drop. So when this scope leaves, and it takes ownership of the result of this parse call, and returns it, then that lock is released. So you don't have to worry about lock and unlock explicitly because this returns a guard, which when dropped will release the lock. Now with the NIF APIs, you can look at them, but you would need to do your own locking and unlocking. So that's the main difference. And I think that it's important to note that those probably are under, this mutex and the enif mutex are probably underpinned by the same operating system primitive. So it doesn't actually matter whether, they're just threads, right? You're operating inside the VM right now. You're not operating in interpreted mode. If you lock, or if you block on trying to acquire this mutex on a thread, that thread is going to get parked until it can acquire it, right? So I don't know if that answers your question, but the thread safety in Rust is about sharing memory, not necessarily about these locking primitives. Okay. Right. Okay, so what we did here is we added this parser parse, but we didn't add it to our Elixir module up here. So we basically need to do this. We'll say parser parse, and we'll give it, and this is going to take 2 arguments. It's a parser and the text. Okay, so now we should be able to compile. Right, so now it can bind it to that module. Now this is not going to return anything useful, but let's do it anyway, because that's what we're here for. NIF parser new, make an Elixir parser, and then let's say true, so p equals v1. So if we did this correctly, then we won't crash. We won't crash the beam right now, although I'm a little bit nervous. Okay, so we want to pass the parser, right? And then we want to say a def module foo do and Cross your fingers, everybody. Okay, it returned something. We have no idea what it is, but it didn't crash. And you can see that, like, based on the numbers in this is sort of like what the internal accounting of the VM. That is actually a different object from P. So yeah, I think that this we got through a lot here. We learned a lot. And yeah, and honestly, this is not so bad. This sometimes feels a little bit better than doing WASM bind gen. Because then you got to worry about binding to all the web APIs, and that's for regular work, not for fun time. Okay, let's close this. So then let's look. We could get a tree. The next thing we might want to do is do something like root node, so we can get a node and implement some of those things. Again, these have lifetimes on them, which might make things a little tricky. I wonder actually if we could do something like take the env as an argument and then make sure that these lifetimes line up with that, but I don't think that that's gonna make the compiler happy. Okay. Yeah, let's go for another 10 minutes or so. And maybe I don't need to do any of that. Maybe we'll do reset. Okay. There's some stuff about timing here that I don't really know that we need to be concerned with right now. So we're doing this on a dirty CPU thread, right? Maybe that would only be relevant if we want to have a tight feedback on whether it succeeded. Okay. The other thing we could look at is tree cursor. This has some interesting stuff on it. Excuse me. Again, with the lifetimes, this will be interesting. Because we'll be passing this stuff back to Elixir and then back to the NIF and then back to, so like we might have to do some tricks. And essentially, so to be clear, the reason why this is node, why it has a lifetime is because it's borrowing from this tree. That's got to be the only reason, right? So like, and some of this is that, you know, the actual tree sitter library is in C, and this is like, hey, I contain a pointer inside this tree, and you're going to call this FFI function tstree root node, and I'm going to do that in unsafe because this is FFI, and then yeah, and then I'm going to create a new node from that pointer to that root node that the C code gave me, and yeah, so this node type let's see if we can find that. Struct node. Yeah, so this, it says it's borrowing, but that's really just phantom data because this FFI TS node is just a pointer, right? It's just a pointer. So it's basically informing Rust that this thing has a lifetime, or that it borrows from the tree. Okay, let's... I don't know how we can adequately erase that lifetime when we are passing it back, but let's see what happens. Let's try to get... oops. Let's make a new one. I don't think it's going to need dirty CPU because it's not parsing, it's just pointer arithmetic. So let's do a tree root node, right? And this is going to take a tree, which is a resource arc, parser tree, and then it's going to return a resource arc of parser node. And we'll see what we can do here. I don't know what's gonna happen. So let's go over here. So there's going to be a tree. We need a node resource, right? And this, interestingly, let's see, can you mutate it? I don't think so. Because all your edits happen at the parser. Or on the tree itself, not on individual... Well, there's edit. Okay. This function is only rarely needed. Let's ignore that for right now. Let's just say it contains... it contains a tree sitter node. And I know the compiler is going to complain to me right now. I can feel it in my bones that I'm not specifying the lifetime on here, but we're going to try it. And let's see what it actually complains about. Okay, so there's lots to say, apparently. Right, so there needs to be a lifetime parameter there. Yeah, const cvoid cannot be shared between threads safely. So this is not sync. Therefore, it cannot be a resource. Right, so let's try to appease it by putting lifetimes on here. Right? And it's probably still going to complain. Yep, there's a lot to complain about. Right, explicitly indicate the anonymous lifetime. Let's try that. Oops. Hello. Give me back set. Okay. Let's do the anonymous lifetime there. See if that works. Probably not. Okay. Struct TS node. Okay. The trait sync is not implemented for const c void. So I honestly think that the answer might be what type would make this sync? Like if we embedded, if we wrapped this node in something, what would make that sync? I think the guarantee would need to be that you can't mutate that at all. The other option we could do is we can tell the compiler we think it's sync. Like we could do unsafe impl sync for node. And do that. I don't think that we want to do that though. That's not good. So we have some things to think about here. Right, remember this is the lifetime of the tree. Now we could do say static. And I don't know that that's going to work. Probably not. Yeah. It's like, you lie to me. You lie. Okay. Yeah, const c void cannot be shared between threads safely. So right, because it proves the node static. Right, so this FSTS node. Required by a bound and resource type provider. Right, so you can only implement a resource if the thing is sized and send and sync. What's not clear to me is I'm sorry. What's not clear to me is when would it be safe to share that node struct at all? And the other thing is if that's the case, how is it that we can make the tree sync? Is it just that this node is intended to have a short lifetime? I'm guessing that that what they're saying is this needs to have a short lifetime. Now, what we could do potentially is rather than directly giving back the root node, we construct an Elixir struct which represents all the important things from here. So like we could say we could have it contain ID and kind ID and kind. We can skip language because we know what it is. His name, just make a bunch of fields in an Elixir struct and then fill these in. And maybe that's the best thing to do. Range usize, byte range, and range. There are some things here that I wanted to do anyway, like this point struct is something that's like ripe for converting to an Elixir struct. some of these methods might not work, but maybe all right, I think this is probably a good place to leave it. I don't see any way forward with this right now until I understand what the goal of the API should be in this case, and maybe there's some other route we need to think about. Maybe the tree exposes some things for getting at nodes in a way that we don't have to deal with this lifetime thing. The lifetime exists only for the inside of the NIF, and then we return some data that represents that thing from the outside, and that we can easily track back to the original. I'm going to give that some thought. Okay. Maybe a reference count tree and cast away the lifetime. I don't know that that gets around the sync problem, unless you're talking about creating an RC. But RCs are not sync, right? Or RCs not send. Yeah, I think they're one or the other. I always get them mixed up. I think it has a negative impl, or no, it's just because it comes from unsafe cell. Go watch the Crust to Rust. I'm gonna have to go watch those again on smart pointers. John Who has good stuff. Yeah, and I want to, as much as possible, it's a good point. That would get you into unsafe lane fast. I want to avoid unsafe where we can. I think it's pretty reasonable that we could avoid unsafe. We're gonna have to do a lot of mutex arc stuff to get there. But let's do that another time. All right, folks. I'm going to wrap it up now. Thank you for coming. Isaac, thank you for being such a prolific chatter. You really kept me thinking about important things, and thank you all for coming. I hope you had a good time. We may get back to the hard hat again next time. But I love that this kind of crosses the two topics that I've been wanting to do on my stream, both Elixir and Rust at the same time. So don't worry about the distractions. This was great. Last time we had a really prolific commenter who was someone who maintains the Tesla library, and that was really great. I do appreciate it. All right. Thanks, everybody. See you next week.